8.1. The Pythagorean Theorem and its converse. Number 1. What is the value of x in simplest radical form? So let's take a look at it. Well, the Pythagorean Theorem is a squared plus b squared equals c squared. A and b are the legs of the triangle, the two that make up the right angle, and c is the hypotenuse, which is the largest side, which is across from the 90-degree angle. So substitute 12 and 5 in for a and b, and square them, you'll get 144 plus 25 equals c squared. Add them up, you get 169. Now to get c from c squared, you take the square root. So c is going to be 13. So let's type that in. So x equals 13. And that's number 1. Going to number 6. Does the set of numbers form a Pythagorean triple? For it to be a Pythagorean triple, the three numbers must satisfy the Pythagorean theorem. So let's put them in and see. So we have a squared plus b squared equals c squared. Put the two smaller numbers on this side and put the largest number in for c. So we square everything and we get 576 plus 100 equals 676, which is true. So those three numbers do form a Pythagorean triple. So we're going to choose yes because the given numbers satisfy the equation a squared plus b squared equals c squared. And that is number 6. Number 8. Find the value of x. So in this case, x and 2 are a and b, and 5 is c. Now it doesn't matter which one goes in for a or b, because addition is commutative. So now we square the numbers, so we get 4 and 25. Subtract 4 on both sides, and you get 21. Take the square root of both sides, and you get b equals the square root of 21. So let's type that in. It says to use radicals, so square root of 21. And that's number 8. Number 10. A 17-foot ladder is placed against a vertical wall of a building, with the bottom of the ladder standing on level ground 9 feet from the base of the building. How high up the wall does the ladder reach? So let's take a look at it. So drawing this out, here's our building, here's our 17-foot ladder, and the ladder is placed 9 feet from the base of the building. So since this is a right triangle, we can use a squared plus b squared equals c squared. 17 is going to be c, and 9 can either go in for a or b. So now square the numbers, we get 81 plus b squared equals 289. Subtract 81 from both sides, and you get 208. Take the square root of both sides, and you get the square root of 208, which is approximately 14.42. It wants us to round to 2 decimal places. So let's type that in. So I'm going to type in 14.42, and that's number 10. Number 11. Is the triangle a right triangle? Well, let's take a look and see. So using a squared plus b squared equals c squared, 3 and 6 are the two smaller sides, so they go in for a and b, and a goes in for c. Squaring them, you get 9 plus 36 equals 64. 9 plus 36 is 45, which doesn't equal 64, so this is not a right triangle. So let's choose that. So we're going to choose no, and that's number 11. Number 12. The lengths of the sides of a triangle are 5, 12, and 13. Classify the triangle as acute, right, or obtuse. So we have to use the Pythagorean theorem. Now if c squared is larger than a squared plus b squared, then the triangle is going to be obtuse. If c squared is equal to a squared plus b squared, it is a right triangle. And if c squared is smaller than a squared plus b squared, it is acute. So let's see which one this is. Well, c will be the largest number, and a and b will be the two smaller ones. Squaring them, you get 169 and 25 plus 144. 25 plus 144 is 169. Since these are equal, it is going to be a right triangle. So let's choose that. This is a right triangle, and that's number 12.